My name is Fabio Arciniagas, and I would like to introduce a text analysis project called Identify Shills. Installation is pretty straightforward. Just copy paste these three lines from the README. But you might be wondering what a shill is.
The only man who sells empty boxes is the Undertaker. And by the look of some of you lot here today, I'd make more money with me measuring tape. Here, one price, £10.
Did you say £10?
Are you deaf?
That's a bargain. I'll take one.
We try to identify shills using three heuristics. First one is strange topics that lead to very high ratings. For example, this person is talking about things that nobody else is talking about, and his rating deviates significantly. Second heuristic is language that doesn't predict the sentiment at all. There are plenty of things wrong with it, 5 stars. The third heuristic is apologetical or backhanded language that occurs when you're trying to sound objective but have to give a positive review. There's a whole interface, so the usage is pretty straightforward. You just type in the movie and that will get scraped from a site live. Then we generate the topics using LDA, particularly collapsible base, which is fast in meta, but not fast enough to be synchronous. So we wrapped everything within its own thread and make the UI responsive through channels. The first chart that you see after processing is parallel coordinates of all the topics. So the pi distributions of each document are going to sum to 1 across those across all those topics, and this is more clear if we first make only 2 topics, similar to the background versus the background vocabulary versus the one topic. After it is done recalculating, it will show just the 2 topics, and just like before, you can see topics that have much on one side, they will have less on the other side. Documents that are slanted towards one topic will have less on the other one, and so forth. Same idea, but using parallel coordinates, we can show all of the arbitrary number of topics that you have selected. You can also drag across any one distribution, so you can see very uncommon ones, for example, how they are distributed across the topics. This is of particular importance to us, as I'll discuss in a moment. Another way of seeing topics and also ratings is through just their distribution. So we're very interested in the combination of 2 things for our first heuristic. First, we're distributed in strange ratings, ratings outside of the norm. Second, we're interested in strange topics. So we're kind of interested in outliers of these 2 distributions. So using this notion of outliers, we're going to capture the first heuristic as a score. We start by figuring out the Z-score of the dominant topic for a review. In other words, how rare that topic is. And we do the same for the rating. Is this a typical rating? We have a threshold of Z-scores for each one of these measurements. Usually a Z-score is considered an outlier for 3 standard deviations. You can change that in the UI. And what we do for each review is we normalize the Z-score by the threshold for both the dominant topic and the rating, and we combine them into a harmonic mean. And that is the third value you see next to the total score inside the parentheses for each review. For the next portion, we are going to predict the rating, which is a sentiment analysis problem, but instead of just saying the polarity, we're going to have bins. And this is something that you can do with meta as well by using ensemble methods and essentially repeatedly doing classification, binary classification. But I chose a different mechanism. I am using text blob to come up with a polarity, and then I'm binning the polarity. The Sankey diagram that you're seeing is basically a generalization of this idea that if you had ground truth in one side and your classification on the other, you would only have diagonals when you had a false positive or a false negative. But here we have many more categories. So we have these lanes flowing from the predicted value to the ground truth value. And roughly they match, but we are very interested in those that don't and those that dramatically don't for the sake of our heuristic. The idea for the implementation of the second heuristic comes from the literature, where they identify that big gaps are very reliable. It's easy to identify and agree on big gaps of 2 and 3 stars, or even less. Here's another mapping. The idea is to identify not these that map pretty well 5.0 to 5.0 and so forth, but bad ones like this. We predicted that it was 5 and it was indeed a 2, or other examples that you see as I browse through here, like we predicted it was a 3 and it ended up being a 5, or a 1. So we have our two bins and we want to model the importance of the difference between them. And of course this is a heuristic and many things can go wrong with that. The intuition itself might be wrong to begin with. The heuristic might not capture the intuition and the implementation might not do well capturing the heuristic. But keep in mind that this is an exploratory project meant to be a playground for libraries and statistical ideas relevant to text analysis. This exponential decay form is useful because it grows asymptotically to 100 and it only starts being suspicious, meaning above 60%, around big differences, like 3 notches. The negative decay rate is something that you can change from the controls, and as you can see, it affects the final scoring of that one parameter. With larger values, you're going to have steeper curves that approximate 100% faster. So the differences will be more pronounced. If the item was classified accurately, it won't matter. So if it was 0, it will remain 0. But if there was a difference, it will be exacerbated. The final heuristic is capturing this middle number, which is actually a binary classification, so it can only be 100 or 0. And what it is a classification of the language as backhanded, apologetic, somehow shady, versus not. Now, it wasn't possible to find an already existing data set that would classify things that way, so I had to create a efficient mechanism to manually classify them, and that is what you're seeing now. This is a particularly good example of that kind of language. After creating manually a set of samples, and one is included with the initial clone, you can create at any point a new classifier by asking under the language style controls an update before the next evaluation. This will create a new classifier against which new or re-evaluated movies are scored for this heuristic. And here I do have to point out a shortcoming of the system, and is that there is a huge disparity between the positive examples for the trainer against the total. There is definitely literature addressing this problem of very few positives, but frankly I didn't get to implement it, and we use a basic classifier. So that's definitely room for future work, and this is the very simple formulation of that final heuristic, which takes us to the weighting of the final score. So as you can see on the combination weights, we can give not only the final threshold for what we consider a Shills score, but the individual weights for each one of the heuristics, less for backhanded language and more for the other two. This is set purely empirically, so you can play with it and recalculate at any point. And with that, we conclude our tour of the features. What we have seen for this shield detection is that we can scrape a movie, and after that apply sentiment analysis, topic analysis, and classification, combine those weights, and come up with a classification for each one of the reviews. Along the way, we have created some graphs to help us with the analysis. The code is on GitLab, and if you have any questions or comments, please reach me by email. Thank you.